Look at this calculation. It feels completely right. It looks perfectly logical. But if you write this down in your physics paper, it instantly ruins your grade boundary. Section 1. The hidden exam track. Okay, put yourself in the exam hall. You're sweating over an energy or pressure question. You need to calculate an area. You take 20 centimeters, multiply it by 1 centimeter, and you get 20 square centimeters, right? Then you remember you need standard units, so you divide by 100, which gives you 0.2 square meters. Honestly, it feels super smooth. It looks exactly like standard everyday math. But let's pause here and really think about this. Would the Cambridge examiner actually give this full marks? If you confidently write this down in your 0625 paper, are you locking in that top grade? No way. The answer is 0 marks. It is a complete fail. And the reason why is buried right here in the official Cambridge Math Skills practice page. This exact trap catches literally thousands of students every single year. Why? Because they treat an area conversion exactly the same way they treat a simple linear distance conversion. Ordinary revision almost always misses this. We're going to break down exactly why this happens and how you can bulletproof your answers from here on out. Section 2. Master the SI units. Before we can fix that disastrous area calculation, we've got to master the non-negotiable examiner language of basic units. This brilliantly illustrates where everything starts. Using the correct, standardized units means examiners can compare the size of variables and calculations seamlessly. That's the whole point of the International SI system. Your basic SI units are the meter for length, the kilogram for mass, and the second for time. Think of these as your absolute foundation. Now, what's really interesting here is how we build on that foundation. From those basic units, we construct derived units. It's like building a house from bricks. This is exactly why energy is measured in joules, power is measured in watts, and force is measured in newtons. You absolutely cannot calculate joules correctly if you're accidentally feeding the equation kilometers or minutes. The base units must be perfectly aligned first. So the crucial point is this. When your distance and time are measured in meters and seconds, your speed must be derived as meters per second, not kilometers per hour. It sounds incredibly obvious right now, I know, but under intense exam pressure, students constantly mix these up. Meters per second is a derived unit because it's fundamentally based on a calculation of those core SI units we just talked about. Section 3. The unit conversion danger. In a moment, I'll show you the examiner clue that changes the answer completely. But first, you need the framework that makes that clue obvious. Because if you don't fully grasp the underlying mathematics of scaling, you're going to walk right into the trap we saw at the very beginning of this explainer. Okay, here is the absolute core of the unit conversion trap. The trap is entirely in the scaling. While you divide by 100 to convert standard linear centimeters to meters, you must divide by 10,000 to convert square centimeters to square meters. And for volume, it's 1,000,000. Let that sink in. There are 10,000 square centimeters in a single square meter. It's a massive difference. Looking at this side by side, the difference is just staggering. The flawed answer drops all its marks by mistakenly using a linear conversion, dividing by just 100 for an area calculation. Meanwhile, the top-band student correctly applies that 10,000 factor, arriving at the correct answer of 0.002 square meters. Think about it. If this was a calculation for pressure or energy transfer, that one wrong conversion just destroyed the rest of your math. You'd be off by a massive margin. Section 4, the high mark framework. To survive these traps, you need a solid system. You have to stop just guessing numbers and hoping for the best. Instead, you need to use a specific, repeatable sequence. This 4-step framework is your armor against dropped marks. First, the concept. What physical property are you actually calculating? Second, evidence and data. What are your numbers, and crucially, what are their current units? Third, scientific reasoning. What is the correct conversion factor, like dividing by 10,000 for area? And finally, examiner wording, writing down the final answer with its proper derived SI unit. Stick to this, and you're golden. Section 5, the examiner correction. Let's look at how the examiner actually corrects and grades these mistakes, particularly when you're dealing with tricky topics like energy stores and efficiency. The examiner reports explicitly flag these exact issues year after year. The top reasons students fail to secure full marks are missing units entirely, rounding their numbers way too early in the calculation, providing vague explanations that completely lack scientific terminology, and failing to spot wrong variables or graph axis scale errors. You literally have to be precise every step of the way. Let's apply our framework to a classic mistake. A vague student writes, energy transferred is 5,000 and immediately loses the mark. Why? Because 5,000 what? Apples, kilometers, degrees. But applying our framework ensures the specific SI unit, in this case the joule, is firmly locked in alongside the data. Energy transferred equals 5,000 joule. That right there is how you secure the mark. It's that simple, but so easy to forget under pressure. And looking closely at the source diagram here, we find the absolute safest method to avoid the area trap altogether. Do you see it? The safest method is to convert your initial linear units before you ever do the multiplication. Change your 10 millimeters to 1 centimeter, or your centimeters straight to meters first. If you multiply using standard SI units from the very start, you never even have to worry about dividing by 10,000 later. It's a real game changer and saves you so much headache. Section 6, your next exam challenge. You now have the ultimate framework to beat the conversion traps. You know to check your base units, and you know the danger of area scaling. But there's a bigger threat lurking. Think about this. What happens when you apply perfect conversions? Your math is flawless, but the examiner has hidden a sneaky scale factor, like milli or kilo, deep inside a graph's axis. Your perfectly calculated joules or watts could still be off by a factor of 1,000 if you miss how the graph is structured. That is an incredibly common way to lose marks, even for top-tier students. So, if a single millimeter or a hidden kilo on an axis can destroy your entire calculation, how do you map out your final week of study to ensure you catch every single one of these hidden threats? To survive this unresolved problem and rebuild your exam strategy stronger, you must watch our next explainer mapping out your final 7 days of revision. Subscribe to our YouTube channel Ace the Exams at aceexams_IGCSE to excel in your Cambridge examinations. Are you ready to beat the examiner at their own game? Click the video on screen now and I'll see you there.